Okay? Proofs are like freak people out. I don't know why. They're really not that hard. People focus way too much, and this is what I'm going to tell you. You focus way too much on how many steps. Okay? Now, when you're doing it on Alex, you have to put more steps because it'll only allow you to put one thing in each step. But typically, that isn't how it goes. Here's what I want you to write in your notes, and this is the important part. In your notes, there's really only 3 aspects to a proof. Now, it may take you a lot of steps to do it, but here's what it is. You want to list the given and understand the given. Okay, you're going to list the given and understand the given. You're going to define the given. Okay, you're going to define the given. Then you're going to transition. And finally, you're going to transition to what you're trying to prove. That's kind of like all one step, but you're going to transition to what you're trying to prove. That's it. Every proof is that way. Will every proof have 4 steps? No, it may have 7, 8, 9. It doesn't matter how many steps. Everybody gets caught up on, well, how many steps are there? Well, who cares? You're going to do this process every time. You're going to list the given. You're going to define the things of the given. This transition step is the key. How do you go from what's being defined to what you're trying to prove? This is the only real thinking step. Okay, everything else is really quite easy. Okay, we'll do one right here, because these are the type you're going to have today. So there's 2 main types I want you to understand. One is a segment proof, and then one is a parallel line proof. So let's talk about the parallel line one first, and we'll see if you can remember this. And I'm worried that you don't, because I don't know how far you got last year. And so I don't know if you quite got this far. Did you? Okay. Because I'm worried that you didn't. But with the parallel lines, there's some certain things I know. If I call this 1, 2, 3, 4, 5, and 6, and 7, and 8, I'm going to ask you some stuff. You tell me what they're called. You might have forgot. 1 and 4 are called what? What type of angles?
Vertical angles.
Vertical angles. Might want to write down your notes if you didn't know it. If you already know it and you don't have to write it, I don't care. 1 and 4. 1 and 4 are vertical angles. What is vertical? They're across 2 intersecting lines. They're straight across from each other. Okay? And those vertical angles are always what? Angle 1 and angle 4.
Equal?
Congruent, yeah. Equal in measure, congruent. Okay? So they're congruent to each other. Okay, that's nice. Was that hard? No. And that's called what type of angles?
Vertical.
3 and 2?
Vertical.
5 and 8?
Vertical.
6 and 7? You with me?
Vertical.
Okay. How about 1 and 2?
Supplement? Wait.
Now, you see, you're starting to think you're on the right track. Which one is it though? Supplementary.
Supplement.
Complementary, and you might want to write these in your notes because you probably forgot some of this stuff. Complementary means it adds to 90. Yeah, so you'll see that when you see a 90-degree angle like this, and then you have one coming through here. That angle and this angle are what? Complementary. You see what I'm saying? So you'll have some complementaries also. This isn't one of them, but you can have complementary angles. But that's complementary, and 1 and 2 are what? Supplementary. You might want to write that so you know what it means. What does supplementary mean then? Yeah, they add up to 180. There's another thing that this is called. That's also called supplementary, or a linear what? Pair. Now, a linear pair is a little more specific because linear pairs can only be 2 what? Angles. Let me show you an example here. Angle 1 plus angle 2 plus angle 3 are what? What would I call it? Supplementary. They will still add up to what? 180. Angle 1 and 2 here on the left, those are for sure what? A linear pair. Now they're also supplementary because they'll also add up and equal 180. But supplementary just means it adds up and equals 180. A linear pair means there's only what? Two that are adding up and equaling 180. Okay, so just a little more specific, but both those are fine. Okay, now we're going to get into the hard ones that people forget. Okay, how about 4 and 5? Or 3 and 6? What do we call them? What?
Alternate something.
Alternate? Interior, because they're inside the parallel lines. Very good. Okay, so angle 3. And by the way, 3 and 6 are what? They're also congruent. And those are alternate interior. The key words, and let me explain what these mean. Alternate means you're alternating. Like, if we were alternating this row to this row, we would go from this row to this row, from this row to this row, from this row to the, right? That's alternating. So alternating just means you're going to the other side, and then back, then other side, and back. So we're going alternating along what this is called the transversal. And we're alternating from one side to the other against opposite parallel lines. Do you understand that? That's why it's 3 and 6, and also 4 and what? 5. Now, 3 plus 4 would be 180, right? But so 4 and 5 are congruent, but 5 and 6 aren't. You see what I'm saying? But 3 and 6 are congruent. They're alternate interior. Okay, using that same logic, what's 1 and 8? Alternate exterior, very simple. Okay, they're on the outsides of the parallel lines, so you identify the parallel lines. The outsides you alternate across, they're also congruent. Angle 1 congruent to angle 8, and those are called alternate what?
Exterior.
Exterior. Okay? There's only one more. These are harder to identify, and there's more of them. And people mess these up all the time. Okay? 1 and 5, 2 and 6, 7 and 3, and 8 and 4. Those pairs.
Corresponding?
What are they called? Very good. Yeah, they're corresponding. Most kids forget those. And yet that's what all these others are based on, is that these are corresponding. So 3 and angle 3 is congruent to angle 7, and angle 4 is congruent to angle 8, and angle 1 is congruent to angle 5, and angle 2 is congruent to angle 6, and all of these are called what?
Corresponding.
Corresponding angles. Okay? All right, I want you to prove, now we're going to get into the proof side of it. Very simple to do, actually. Prove, given, this is what I'm going to say. Let's do it the way that it would be written. Given that 1 and 5 are corresponding angles, given that 1 and 5 are corresponding angles, prove that the alternate exterior angles of 1 and 8 are congruent. Given that 1 and 5 are corresponding angles, prove that 1 will equal 8 as an alternate exterior angle. Prove that 1 is equal to 8. Okay? So I'm going to write that. So given is what?
1 and
Angle
5.
1 is congruent to angle 5 because of what?
Corresponding.
Corresponding angles. Okay, that's the given. I want to prove that angle 1 is congruent to angle 8, which is really proving that alternate exterior are congruent. Okay, this is a very simple proof, really easy. So this is my first step. By the way, all proof is we're going to always do 2-column proofs. Okay, I'm not going to get in, there's a whole bunch of others you can write, paragraph proofs, and it's just all bull crap. This is the key way that you need to be able to do proofs, because this is really what we're asking. You make a statement, and then you give a reason for the statement. Okay? It's like when you come home late at night, right? You're a little late. Where were you? What do?
Make a reason.
You make a statement.
Or statement.
You say, I was out with whatever, right?
Traffic.
Well, what happened? Now you got to give a what?
Reason.
Reason. You see what I mean? Yeah. Flat
Had to
tires.
change
There are
the
so many flat
tire.
tires in Emily County. At least when I have teenagers. Don't know why. Okay. So I'm like, wait, it has the same tires on. Oh, we just bumped it up. Okay, how did you bump it up? I thought you were in the middle of nowhere. Yeah, I gotcha. Don't be messing with a math teacher. All right. So anyway, statements versus reasons. That's all you're doing. Okay? That's all you're doing. So the first statement I would write, this is where the math goes, and this is where the English, I put, it's not really English per se, but it's where the sentence goes, okay, or the reason. And really, it's not even a sentence, it's just you write it out. Okay, so angle 1.
It's congruent to angle
Congruent to
5.
angle 5. The reason is given. Everybody agree?
Yes.
Okay. Now, really, I don't have to define that. Okay? Congruent means equal to. I mean, I could define, I guess, congruent. I could write definition of congruency, which means the angle, the measure of the angles are equal. But do I need to do that? Not really. Now, the key thing is the transition. Notice I have 1 in the first statement, and I have 1 in the last statement, but I've got to connect 8 to 1 through 5. This is the important part. Watch what I have. In general, this is all I'm looking at. I have 1 and I have 1. You see what I mean? That's good. So that part I've already kind of got in what I'm given. But somehow I have to connect 5 to what?
8.
8. I've got to connect 5 to 8. So now I look at the picture and I think about 8 and 5. How do I connect those?
The vertical.
They're congruent. Why?
Vertical.
See, that is the proof, really. Like I said, the only real part of your thinking is the transition from here to here. What do I have to do to transition? Well, somehow I got to connect. It's like a murder case, right? I'm reading a book, the Lincoln Lawyer book. And in the Lincoln Lawyer book, he's got to connect. He has this guy called Alperazio, right? And Alperazio is a guy that he put on the stand and pinned a murder on. That maybe Alperazio didn't even do. But Alperazio was a bad guy, and he's a mob boss type of guy. And he's like, I don't even care if he did it. I could prove that it was close enough to being him. It probably wasn't him specifically, but he might have ordered it. So he's like, I pinned it on him. Well, now Alperazio comes back and actually puts a dead body in his trunk, and he's driving around with this dead body, and then the murder gets pinned on him. So now he's got to connect Alperazio to the murdered guy in the back of the truck. You see what I mean? You have to connect the dots. You have to make that go. That's what we're doing here. We're just connecting the dots. It's like a murder case. Okay, I'm trying to connect angle 5 to angle 8. How do I do that? Well, I look at the picture and I see, how do they connect? How does I connect 8? You guys all said it. Angle 5, step 2, angle 5 is congruent to angle 8. How?
Vertical.
Vertical angles. And that's my reason. So don't get so caught up in how many steps there are. I don't even care. This is a really simple one, obviously, but I just wanted to show you. Okay, now I have a connection between 5 and 8 and 1 and 5. The next step is kind of the key step. I know that angle 1 is congruent to angle 8. How did I get there? Is 1 equal to 5? Is 5 equal to 8?
And 1's also equal to 8.
How come 1 is equal to 8 then?
Because they're both equal to 5.
Yes! What is that called?
It's a property, but
It is a property.
I don't remember what it
I'll
was.
tell you the property. How many of you listen, or have ever listened, I guess, to the Arrow on the radio? Does anybody listen to the radio anymore?
No.
Some people don't. The Arrow, you might have listened to the Arrow on the radio, or you might have listened to, what's the country station? KSLP. You ever listen to KSOP on the radio?
Yeah.
Okay, let's say you're listening to KSOP, okay? So what does KSOP broadcast on when you're up in Salt Lake? Anybody know? Like what channel is it?
Is it
104.3, okay? If you're in towards Carbon County, what station do you get it on?
106.7.
106.7,
7.
okay? What if you're in Farron, Emery County?
It's 106.7.
It's the same.
And this is actually 106.3. 106.7 is the peak, or whatever that is. Okay? So 106.7 is from Price. 98.3.
That was the peak.
Okay, but that's what I'm saying, is 106.7 is the same,
Okay.
as the same station. The country station in Price is 106.7 here. Trust me. KSOP is on 106.3 in Price, and it's on 92.1 if you're in Farron. Trust me.
Trust
But it's coming from Salt Lake.
Two more.
Yeah.
We have our station.
We have all of them.
Yeah.
Yeah, I've used all of
Do you
those.
live in Farron?
I do.
Oh my gosh, you've never listened to 92.1.
No, I listened to 106.7.
Well, 106.7, okay, there's another station, it's 98.3.
Mhm.
So this is KSOP. 98.3 goes to 106.7, and I don't know what this is called. Is it? I don't know if it's called the Peak, is that what it's called?
Yeah.
Or Kicking Country, or?
Kicking country. Kicking country.
Okay. Okay, that one's this one. Okay, but we'll still make the same idea. The same idea works for both these. Why are we listening on these when it's really being broadcast on that?
It's too far away.
It is.
Welcome to Emery
So what does
County.
it go through? A transmitter. Where does the transmitter sit?
That was a guess.
That's totally right. Where does the transmitter sit?
On the mountain.
Which one?
The big one.
Horn Mountain. Horn Mountain. Okay? There's actually a lot of transmitters.
I didn't even know it had a name.
Okay, because it's the highest peak. So it goes up, hits Horn Mountain, comes back down. So really, watch. This is the key. And by the way, this is where we get, I like using this example because this is called a what?
Transition.
Transmitter. But the property is called the what? Transitive property.
Oh,
The transitive property in math says this. If A equals B and B equals C, you hear it, you hear the exact same thing the whole time. Okay, so this little triangle right here, that little triangle right there is really truly the what property? Transitive property. So that's really my reason right here. Okay? The reason that 1 equals 8 is just like Sabrina said, it went through what? 5. They were both equal to 5. So therefore, 1 has to also equal 8. That's done by the what property?
Transmit.
Transitive. That's an important property now. Now, some kids would say, well, I just replaced 5 with 1. Is that true? Yeah, you did. Look, 1 equals 5, 5 equals 8. I'm going to replace 1.
So can that
I'm going
be
to replace the 5 with 1. What's another reason I can't gauge? Substitution. Both of those are legit. Transitive is more what this one is, but substitution is a little bit different. Substitution is when you replace only a part of it, not exactly the whole thing. Here we really replace the whole thing. Okay? All right, I'm going to give you another one. Okay? That was a simple little proof. Okay? Not very hard. Just 3 steps. This is going to maybe have a few more steps. Okay? And this one we'll do as a linear thing. Okay, so draw these 2 lines. We'll put a point right here. A, B, C. And here we'll go X, Y, Z. Okay? All right, given xy is equal to, oh, by the way, I'm going to show you this too. xy is equal to bc. xy is congruent to bc. This is just little notational stuff. It's petty and I hate it, but sometimes I'll make you do this on these. Congruent, you put a line over it because this is saying the segment is congruent to this segment. This is saying the measure is equal to the what? Measure or length. The length or measure is equal to the length and measure. But it doesn't, are they really saying the same thing? Yeah, I don't make a big deal out of that, but sometimes you'll have it on like Alex or something that'll make a big deal out of that. Or there'll be a missing step and all they did. And by the way, that's just definition of what? From there to there, if you had to do it, would be the definition of what? Of congruency. That's all it would be. Remember how I said the second step is sometimes defining the given?
Mm-hmm.
That's what you would say, definition of congruency. The definition of congruency of segments means that they are equal in what? Measure. That's all it means, okay? But we're just going to give you that to start with, okay? I'm also going to give you that AC is equal to XZ. And then I want you to prove that let's see here, AB is equal to YZ. Okay, can you do it? Okay, now, here's where the number of steps comes in. If I'm doing this, I'm doing one reason and I'm doing two things in the first step. So if I'm doing this just on my own, now on Alex, they probably won't let you do this. I put a semicolon between two things, but I list them both because it's the same what? Same reason. Remember, these are the statements, mathematical statements. Is the reason the same for both of those?
Yeah.
Yeah, what's the reason? This is what was given. Okay. Now, again, I gotta look at the transition. Where am I trying to go? I'm trying to get AB equaling what?
YZ.
YZ. What am I given? That one's given congruent to that, and the whole thing is congruent to what? The other whole thing. Well, that shouldn't be hard to prove then, should it? I've got to break apart this whole thing. That's kind of the key, right? So that I can get these smaller parts that I'm trying to prove. See, that's what my brain has to do. That's the hard part. That's the transition. So how do I break apart AC so that it includes AB? How do I break apart AC so that it includes the statement of AB? Somebody tell me what I should write.
You say they're both the same.
Tell me what AC equals.
X.
Well, it obviously equals AC. And it obviously equals XZ. But more important, I've already stated all that, right? Break AC down to where I'm including AB as part of the statement.
Oh, it's
AC equals what? AB
plus
plus
BC.
BC. Why? Why?
Because you add them together and it equals the entire length.
Okay, so what's that called? See, these are some of the things, because you have to give a what?
Addition.
A reason. You've got to know what things are called. That is absolutely true, but you have to tell me why. What is A to C? It's a line what? Segment. And you're telling me two smaller segments of that line segment added together equals the whole one. So what's that called? Segment what? What did we do with the two smaller things? Added them together. So it's called segment what?
Addition.
Yeah, don't try and make these like some mystery. Think about what you did. What did I do?
Added.
I added two smaller segments to make a
Big one.
bigger segment. That's segment
Addition.
addition. Now on Alex, they'll have some to choose from, and that you'll see that in there, okay? All right, how about 3 then? Well, that helped me bring out AB. What else haven't I really mentioned? I mentioned all this because it was given, but what haven't I mentioned yet?
YZ.
See, I keep looking back at what I'm trying to prove. This is what kids don't do, okay? They don't keep their eye on the prize, okay? They're easily distracted. They get all caught up in bullcrap. All I really care about, really, is I've got to mention AB somewhere along the line. I just did. But I also need to mention what?
YZ.
Is YZ even up here? No, but is it part of XZ?
Yep.
Absolutely. So, what should I write?
XZ
XZ equals what?
YZ. Wait.
XY plus YZ. How come?
The same.
It's the same reason. Could have I written these in the same? Yeah. But on Alex, it's not going to let you. It's going to make you do this. Because they're two different what? Segments. So they're going to make you do it as two steps. Really, you could put all that as one step. It's the same reason. Just two different segments. Just like the given. Okay? All right. Now, tell me what you know from the given about AC and XZ.
They're equal. Wait.
So tell me how I can put these two things getting closer to being equal to each other. If AC is equal to XZ, how can I get these two closer to being equal to each other? Are these two things equal? If these two things are equal, are these two things equal?
Yes.
The trend.
You said AC equals what?
XZ.
XZ, and now you're telling me AC is this, so can't I replace and say, step 4, A, B,
So would that be
plus
substitution?
B, C equals, and now I also want to replace what? The XZ with this, it's this, XY plus what? YZ, and this is important to say, not just transitive, but what? Which one did we use as also we could say it's transitive? Substitution. This is substitution. Because we didn't go through just one thing, we changed two things. We changed AC to be, you see what I'm saying? And we also changed XZ to be that whole setup. Okay, why did we want to do that? Well, I looked at what I was trying to prove. I had to put AB on one side of an equal sign and YZ on the other. Is YZ over here? Is AB over here? Yeah, that's good. Okay. What's the problem? If I subtract BC over here, is that they're not like terms. But what do I know about BC? It equals what?
XY.
XY. So, step 5, let's leave this one alone. But let's change the XY. What should we change the XY to? BC. Again, that's what?
Substitution.
Substitution. If you said transitive property, two things equaling the same thing, nope, that's not what it is. These two things equal each other, so it's substitution, not transitive. Okay, step 5. What is it? YZ. Okay. Now what? What's my goal?
Get AB equal
AB equaling what?
YZ.
YZ. Am I paying attention to how many steps I have?
No.
No, I don't care. Whatever. I'm not worried about the steps. I just want to get to an explanation that makes sense. What can I do so that AB is equal to YZ going from this step to the next one?
Subtract BC.
Yeah, I'm going to subtract BC from both sides. That will leave AB equals YZ, which is what I was setting out to do. What's the reason that I can subtract BC from both sides?
To get it equal.
Subtraction, what?
Segment attraction.
Subtraction, property of equalities. How come? Can you subtract the same thing from both sides of an equal sign?
Mm-hmm.
That's all I did. I subtracted BC from the left and BC from the left.
Right.
Right. That's it. You can stop that now.